Hey folks, today we're going to talk about ionic naming. Specifically, we're talking about polyatomic ions. Right, so let's go into polyatomic ions. We have to remember for ionic substances we have cations and anions. And when we're talking about cations, they are positively charged, and we have anions and they're negatively charged. And remember, they attract each other because they have opposite charges. So let's look at some Dasani water and let's look at what's in it. When we notice some potassium chloride, now we know what potassium chloride is. We know that potassium chloride is KCl. And we know what salt is, and salt is NaCl. But what in the world is magnesium sulfate? That's an interesting one. Now that's an ionic substance, but we don't know what that is. And what is this 8 business? We know what the ide is, but what in the world is the 8 business? So when we look at ions that are on the periodic table, they all end in ide. So this is nitride, oxide, fluoride, and this would be sulfide. So what's this sulfate stuff? That's not sulfide. Well, polyatomic ions, there's more than one atom in an ion. So what we have is we have ions that are made up of multiple things, and they form ionic bonds as a unit. So they usually end in ATE, they sometimes end in ITE, they even sometimes end in IDE, and all of the naming concepts work the same. But if they end in ATE and ITE, they're definitely not on the periodic table, because everything on the periodic table ends in IDE, all of the anions on the periodic table. So here are some common polyatomic ions, 5 of them. You're going to have a total of 6, so you need to memorize these, so pause the video and write all these down. Okay, so I'm just going to take a couple. Look at nitrate. Nitrate is made up of 1 nitrogen and 3 oxygens, and it has a -1 charge. Right? As a unit. Now, we don't worry about the individual nitrogens and the individual oxygens. We look at this entire thing as one single anion, and it has a 1- charge. We also have sulfate. Oh, that's where the magnesium sulfate comes from. So we have sulfate, and sulfate is SO4. Again, that is a complete thing. It is a unit. You may not break it up. You do not have permission to break it up. It is one thing, and it has a 2- charge. Similarly, we have carbonate, phosphate, and hydroxide. Notice that we do have hydroxide. It does end in IDE, even though it's not a single thing on the periodic table. It is a polyatomic ion, and it has a 1- charge. All right, so let's kind of compare what's going on with sodium chloride and sodium nitrate. Chloride has a 1- charge. That's this guy. And nitrate also has a 1- charge. That's this guy. So when we look at sodium chloride, if you remember from the last podcast, we said sodium was +1 or 1+, and chlorine's 1-, and because they're both 1s, they cancel, so you don't put any subscripts down here. Well, the same thing is true here. Sodium is 1+, and nitrate's 1-, so we do not put any subscripts. Now, you still need the 3 here for the NO3, because that's what nitrate is. Nitrate is NO3. It's not NO, it's not NO2 or NO4, it's NO3. That is what nitrate is. So you'll notice we have nitrate in each one of these compounds that we're looking at. Now, let's go back to magnesium chloride. That's a 2+ charge and a 1- charge. So since magnesium has a 2+ charge and nitrate has a 1- charge, we crisscross those numbers, and you'll notice we have 2 nitrates. Now you'll also notice I put the nitrate inside parentheses. Well, that's important because I want to have 2 of these entire things, and this entire thing, nitrate is a thing, and I need to have 2 of them. How about aluminum chloride? 3+, 1-, aluminum 3+, 1- for nitrate. I cross them. I have to have 3 nitrates. Right? So it's just like saying I have AB, and this is a 3+, and this is a 1-, so I have to have AB with a subscript of 3 because I need 3 of them. That's exactly what's going on here because I need 3 of the whole nitrates, and that's why I put parentheses around it just to indicate that it does need 3 of the entire nitrates. All right. Now, if you did in fact memorize those 5 units, which you probably just have them written down, so go ahead and look at them, and you should be able to name all of these similarly to what we did before. in the last podcast, you should be able to look at these and name them. So I'll name a couple for you. Right? If I look up the top, I see potassium, and SO4 is sulfate. So this would be potassium sulfate. And you'll notice, again, I don't worry about the fact that there's a 2 after the potassium, just like I don't on any other ionic compound. I just call it potassium sulfate. So you go ahead and do these, pause the video, and do them. Alright, I'm not going to write them all down, but I will just read them to you. This is calcium carbonate, aluminum sulfate, cesium nitrate, rubidium phosphate, aluminum hydroxide. Now be very, very careful that you put those parentheses in there for aluminum hydroxide, because you need 3 OHs. It is incorrect to do AlOH3, because that says I have 3 hydrogens. I need 3 OHs. I need 3 hydroxide ions. The hydroxide ion is the entire OH. Make sure you do that. Great test question. Hint, hint, hint. All right. Aluminum sulfate, aluminum phosphate, and magnesium hydroxide. Again, notice the parentheses around the OH. Right? So you should be able to name all of those. All right. We do have one polyatomic cation to memorize, and that is the ammonium cation. And excuse me, and it is an H4, and it has a 1 plus charge. So just like sodium, it's going to have a 1 plus charge. So ammonium chloride would be ammonium NH4 because it's 1 plus, and Cl, that's 1 minus. And ammonium and nitrate, ammonium is a 1 plus, and nitrate's a 1 minus. So you don't add any subscripts. But look at ammonium sulfide. Sulfur has a 2 minus charge, and ammonium has a 1 plus charge. So when I crisscross those numbers, I get ammonium 2, sulfur 1. So it's ammonium sulfide. And what about ammonium sulfate? Well, sulfate also has a 2 minus charge, and ammonium has a 1 plus charge. So when I crisscross those, I get ammonium 2, sulfate. Okay, so we've ignored subscripts pretty much so far. But you need to be able to look at something and crisscross the numbers. Now, guys, this works exactly like it did in the last podcast. Right? You just have to look at what the charges are. Now, what I will do is I'll do a couple for you, and I'll show you exactly how I do it. I look at potassium nitrate, and I say that's a 1 plus charge, and nitrate is a 1 minus charge. I do potassium, which is K, and I do nitrate, which is NO3, and I look at my charges, and I don't have to crisscross anything because they cancel, so I just leave them alone. For potassium sulfate, I write down what the things are first. That's K and SO4, potassium and sulfate. That's a 1 plus charge and a 2 minus charge, so that means I have to have 2 potassiums. So then I crisscross my numbers and put the 2 after potassium. Okay? See if you can do the next one. Pause the video, try the third one. Right? Potassium is K, phosphate is PO4, and potassium is a 1 plus, and phosphate is a 3 minus, so I have to have 3 potassium, so it's K3PO4. How about the last one? Can you do that one? Pause the video, see if you can do it. Alright, 1 plus, 1 minus, so I don't have to worry about any numbers, it's just KOH. Alright. Pause the video, see if you can do all of these, and then I'll go through them with you. All right, welcome back. Calcium nitrate, Ca, NO3. Calcium is 2 plus, nitrate's 1 minus. I cross my numbers. I have to have 2 nitrates, so I have to put parentheses around my nitrate because I need 2 of them. I need 2 of the whole things. Calcium sulfate, Ca, SO4. I have 2 plus, 2 minus. Now, if you remember from the last podcast, we said that when you have a 2 and a 2, they cancel each other out because we want the lowest whole number ratios. They cancel each other out here too. So you have CaSO4. Calcium phosphate. Calcium is Ca. Phosphate is PO4. Calcium is 2 plus. Phosphate is 3 minus. I crisscross them. I get 3 calciums and I get 2 phosphates. So I have to put phosphate in parentheses. And finally, calcium hydroxide. 2 plus. 1 minus, so I have calcium and I have hydroxide, but I have to have 2 hydroxides because of the +2 charge of calcium, so So I have to put parentheses around the OH and put the 2. Guys, if you forgot the parentheses, which is very common to forget them, you must put them in. If you leave them off, that's an incorrect answer. All right. Use your ion chart, folks. You're given one. It's in your packet. You need to use them. You should notice some patterns in them. Right? For example, you should notice that there are polyatomic ions that end in ITE and ATE. For example, we have sulfate, which is 8, which is SO4. It has a 2- charge. But you'll notice that I also have sulfite, which is SO3. It still has a 2- charge. You'll say, well, gee, I noticed the 8 and the ite, and the difference seems to be that that there's one more oxygen in sulfate. Now, Mrs. Can describes this. She says, well, that's because it ate an extra oxygen. Well, that's a good way to remember it, right? So you could also have nitrate. Nitrate is NO3, and it has a 1- charge, excuse me, and so you could have nitrite, and that is going to be NO2, and it also has a 1- charge. So the charge isn't affected, but you're losing an oxygen when you go from an 8 to an ite. Right? So if you want, and you just memorize, for example, nitrate, because that's one of the ones you have to memorize, you can figure out nitrite as well. Now, there are actually other patterns that you're not seeing here, because there is an NO4 with a 1-, and there is an NO with a 1-. Right? And the one with the 8 is called pernitrate, and the one up here is going to be hyponitrite. So the names are very similar, but there are some rules to do this. Right? You will notice that nitrates don't always have a +2 charge, like they do in sulfate, right? Because phosphate has a -3 charge, sulfate has a -2 charge, nitrate has a -1. So that doesn't follow, but 8 always has one more oxygen than the ite does. So here are some rules. I suggest you pause the video, write these down, and this will help you if you know the 8, which is the one that we use the most commonly. You should be able to figure out the ite. You should be able to figure out the hypoite, and you should be able to figure out the per-8. And so you should be able to go in all directions from that information. Okay. That's why we always have you memorize the 8s. All right, use your ion chart. See if you can figure out how to go and come up with the formulas for these. Pause the video, see if you can do it. All right, your first one is barium hydroxide, BaOH. And this is a 2+ and a 1-, so I need 2 OHs, so I have to put a 2 around it. Ammonium, ooh, that's NH4, that's that new one. And bicarbonate, I have to look at my chart for that, and that's HCO3, and that has a 1+ and a 1-, so I don't have to add any additional subscripts, but that's what I've got so far. Right? Aluminum is Al, and bisulfate, well, sulfate is SO4, bisulfate is HSO4, and this has a 3+ charge, and this has a 1- charge, so I have to put parentheses around the bisulfate, and I need to have 3 of them. Again, you're still always dealing with just 2 things, folks. Which you sit here and you say, well, it's getting confusing. If you always work from the concept of you have 2 things, a cation and an anion that you're working with, that should help you. All right, calcium and sulfite. Well, sulfate is SO4, so sulfite would be SO3. That's good, Skip. You know what you're doing, and you said it, and you wrote it wrong. Right? And calcium is 2+, and sulfite is 2-, so it's CaSO3. Calcium sulfate would be SO4. All right. I'll give you a minute, pause the video, see if you can write down the answers. All right, again, the names, the subscripts don't matter when you're doing this, so you just say this would be magnesium and borate. This would be calcium. Now, the CR2O7, you have to look at that because there are a couple in there with chromium, and the CR2O7 is dichromate, whereas the one right below it is chromate. So this one right here is going to be ammonium, and the CrO4 is chromate. So this is dichromate, and this is just chromate. And this is sodium and CO2. Well, CO3 is carbonate, so CO2 is carbonite. So this is sodium carbonite. And this one is a little bit confusing. You see the aluminum and you say, well, that's just oxide, right? Well, no, it's not. You'll notice it's O2. Right? Well, where in the heck is O2? Well, look at your common ion chart and you'll notice that this is peroxide. Remember that peroxide is one additional oxygen. So this is peroxide. So this is aluminum peroxide. You know what hydrogen peroxide is, right? Well, that's something that's important because hydrogen peroxide is something that you use at home. This is aluminum peroxide. All right, see if you can do these. Pause the video, go ahead and do them. All right, your first one is ammonium permanganate. You have to find that on your ion chart, permanganate. And this is strontium, and Cn is cyanide. And cesium and phosphite. Not phosphate, it's PO3, so it's phosphite. This is sodium peroxide. Again, you notice that it's N2O2. You're real tempted to write this as NaO because you want to reduce those two numbers. That's not true because this thing right here, that is peroxide. Right? And this one is barium, and the HCO3 is saying it's very common. This is bicarbonate. So this is barium bicarbonate. All right, folks, you have monatomic, polyatomic ions. You have to memorize 6 of them. The crisscross method still applies here. You need to know how to go from names to compounds, compounds to names. Please do the worksheet, folks. I can't stress that enough. Do all of it. And if you have questions, let me know in class. I'll see you then. Have a good one. Bye-bye.